Hello everyone. This is a video lecture for College Algebra, Math 1414, Section 3.5, Rational Functions. Now, rational, what do I mean by that? Rational is in ratio, as in fractions. Fraction functions. Yeah! When you just thought it couldn't be cooler, it just got even better. So, 353 going right in. They say I got h of x is equal to negative 5x squared divided by x minus 6 and x plus 9. And they say find the domain of this thing. Well, the domain of this stuff is I'm going to ask you a question. Do we have division? Yes. So I want to know when is the bottom equal to 0. I guess I kind of put that in the wrong place. When is the bottom equal to 0? And there's two different answers, of course. We've got a 6, negative 9. And generally, we used to do interval notation, something kind of like that. Not here. Nope. All they want is x not equal to, and you put 6 and negative 9. And that's it. Yay! It's so much easier. Okay. 357. I got h of x is equal to 15x squared plus x, all divided by x squared plus 5, and say, what's the domain? Same kind of question. So I'm going to say, is there division? Yes. Find out when the bottom is equal to 0. And I tried to do some math here. I don't know, move the 5 over. Square root both sides. Plus and minus, I guess. And what you get is plus or minus 5, square root of 5i. So an I in the front, I guess, and then a square root of 5. The thing is that does not change our domain at all. Imaginary numbers aren't important as far as domain is concerned. And so I'm going to say no domain restrictions. Okay, basically it's the negative infinity to positive infinity stuff. But they don't have that as an option, so you just click no domain restrictions. But, well, either way. Okay, well, that was it. Cool. And then they got a weird question here. I think it's about 2 of them here. They called this one arrow notation. But really what you're learning is calculus. Ooh. You're in Math 1414. You're going to be, you're on the path to, getting into calculus. And so this is actually in calculus land. If I could spell calculus. In calculus land, they call it limits. Limits. Okay? But we'll just say arrow notation for right now. And so this arrow notation limit stuff here, we got a vertical asymptote here. We'll be talking more about that in a second. And then 1, 2, 3, 4. We got another vertical asymptote over right here. And then they have some kind of cool graph stuff going on here. Something kind of like that. Okay. So I'm going to use this graph to answer their questions. They say as x goes to negative 1 from the left, f of x approaches what? So as x approaches negative 1 from the left, that's that little negative sign up in the power. It means from the left. So I'm approaching negative 1. I'm getting close to negative 1. I'm saying this is my negative 1 right here. This is that line that I'm talking about here. I'm getting close to negative 1, but I'm starting on the left side. See, you got left side of this thing, we got the right side of this thing. I'm on the left side. I'm going to follow this path. And I want to get close to this line here. Going up, 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 up. Following the line, up, up, up. What is all this up? Give me a y value. Where are we going? Positive infinity. Or just infinity. We're going up here. Positive infinity. Okay. Okay. I think I'm seeing you now. Okay. So now we got, not x, as x approaches -1 from the right, what does f of x approach? So again, that little plus sign up in the power means from the right. Okay, so I'm on the right side now. I'm on the right side of this thing, but it's still that important line. I'm over here. I'm going to try to get close to it. Down, 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 down. I'm getting close to it. Down, down, down. Getting close to it. Down, down, down. Getting closer. Down. Negative infinity, as you probably guessed. Awesome. Okay, I got one more here, but I also want to do a little bit more. So it says, as x approaches infinity, what does f of x approach? Notice that all these are y values. That's what they're really asking for. What's the y value? So as I am going towards positive infinity for my x, I'm going to get closer to it, closer, closer, closer. What's my y value? How high is that going to be? It's getting closer to 0. Notice that I'm trying to get close to this 0 line. And you got to use the graph to kind of see it a little bit better. I'm going to do some quick verbal ones. I'm going to say, as x approaches 4 from the left, what's my y value? These are just my own for a second. Well, notice we got 4 right here. Now I'm on the left side over here of this. I'm on the left side, and there's a right side of this line. I'm on the left side, so I'm going to follow it. Up, 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 up. Positive infinity. Okay, but what about x approaches 4 from the right? Well, again, this is my important number, and I'm on the right side of it right now. I'm going to go down, 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 down. Negative infinity. I've had a lot of folks ask me, they're like, well, I mean, when you say the left side, don't you mean like the left side? Like left side? Well, no. What's the number at concerned? What's the number that's concerning to us? 4. So 4, and I'm on the left side of it or the right side of it, and I ain't going very far. That's it. Don't think that left means like left. It doesn't mean like that. Okay, it means just left of the line that we're concerned about. Okay. Okay, and now we're done. There you go. Let's actually do questions that concern the rest of this section. 3, 5, 25, and onwards. Actually, no. This is a separate question here. But still, let's start talking about before I actually get to this problem. Let's talk about something else on the side here. So as I go through fraction functions, because that's what we're talking about here, I'm going to say that f of x, my function, is equal to a top and a bottom. And we've already been seeing this a little bit. Whenever I go down here, I say, hey, when is the bottom equal to 0? I'm classifying them differently as top and bottom. And so I'm going to use formulas as I keep going, saying top does this or bottom does that or whatever. And that's what I mean right here, okay? Another thing that we should talk about are these things called vertical asymptotes. Vertical asymptotes. I guess you could say that it's when the bottom is equal to 0, okay? And that's these guys. That's these little dashed lines that you can never cross. These little fences. That's a vertical asymptote. And how do you find it? It's when the bottom equals 0. Notice that I'm trying to use that notation, that understanding, okay? Cool. So bottom equals 0, there you go. But I want to have a little caveat to this. It's going to be bottom equals 0 after you simplify. Now, that's kind of weird. Let's just kind of roll with it for a second. I got one last one. We got holes, like holes in your domain. And this is something that we've been seeing for a while, back in chapter 2 and all that kind of stuff. Like when I say hole, I mean like a little circle, that kind of thing. So we've seen it before. In a more technical sense here, we're going to talk about Removable discontinuities. Removable discontinuities. Wow, that's a huge word. Yeah, I'm just going to go ahead and just stick with holes, if that's okay. It makes it a little easier. And what's the formula? Bottom equals 0. Wow, that was so amazing. Well, they're the same. How are they going to be? How do I know the difference? Well, this is things that get canceled. So these get canceled. Again, right now, I'm just kind of given, like, after simplify, what do you mean? Get canceled? What is that? Well, let me show you with this problem here. H of x is equal to x over x times x minus 3. Lots of x's. Well, before I keep going, I want to simplify. Those guys cancel. And then I'm like, hey, do we have division? Yeah, bottom equals 0. And so what we found is x equals 3. That's a vertical asymptote. Again, after simplifying. Didn't I do that? But they're also asking for holes. I'm saying whatever gets canceled. This guy got canceled. Bottom equals 0. Still from the bottom. Whatever got canceled. Well, this guy got canceled. And if you have just x by itself, it means x equals 0. And that's going to be a hole. That's actually your answer right here. That's your answer. You're looking at right here. There's your answer. Now, my math lab is very strange about this on these problems. They're going to say 3 options. They're going to say vertical asymptotes, holes, or they're going to say both. And you're going to click the both, and then they have a box, and then they have another box, and they basically tell you it'll be for vertical asymptotes and holes. There's a lot of English in there. Awesome. So, yeah, vertical asymptote, right? That's a 3 and a 0. They want x equals 3 and x equals 0. Now it'll work. Okay. But here's the next question. Immediately after that, they're going to ask the same thing. Like, this is the next. It's not part B. It's like the next question. They're going to say vertical asymptotes, holes, or both. Okay, and it's going to look very similar. Vertical asymptote, holes, and all that kind of stuff. And then they're going to have an x equals right here. And it's very tempting to just go, oh, I know the answer, and I know they're being tricky. X equals 3, x equals 0. Because you're saying x equals, and x equals, x equals. No. In this case, you actually just put a number. And this is so annoying. It's so annoying because what happens is that we forget this kind of stuff on quizzes and exams and whatnot. And so you're going really fast. You know, you already got the numbers. You know what's going on, but you just forget to type an X, or maybe you type an X and you didn't need to. Just be careful. And I'm going to say this is a very commonly missed problem. If you do get it wrong for some reason on a quiz or exam or something like that, tell me. I can go back and look at it. I can give you some partial credit, whatever. I get that you got the right answers. It was just a formatting issue, and I'm sensitive to that. I want you to succeed. I don't want you to fail because of a computer, whatever, saying whatever about it. Okay? Okay, cool. If it's on the homework, I'm not giving you credit because you could just do it again. And it's a fairly simple problem, actually. That's the point of the homework, right? That we can keep doing it forever. Okay, brand new thing. We're going to talk about horizontal asymptotes. Now, we just talked about vertical asymptotes. Now we got horizontal asymptotes. And I like to call this the 3 rules. So later on, I'll be saying blah, 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 the 3 rules. And this is what I'm talking about. As we go through, do remember that I still have a top and a bottom. So I'm going to say blah, 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 top, blah, 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 bottom, and you'll know kind of what I'm talking about. Here's the 3 rules. Number 1, if the degree of the top is less than the degree of the bottom, then my horizontal asymptote is at, because I want to make it look cool, I'm using the at sign. I'm so hip. Y equals 0. And that's your answer. Now, what I mean by horizontal asymptotes, I mean this thing right here. not just the x-axis, but in that case it is. It's this line where you're not really crossing very often. You're kind of getting close to it, but sometimes you can cross it. Just not often. I would say you approach it over time. In this case, they say it's the x-axis. Actually, before I do this, let's do a little mini example. That way you kind of understand what I'm talking about, because this is a lot of blah, blah. The degree of the top less than the degree of the bottom. What are you talking about? So here's an example. I got 11x, just 11x. I already gave it away. And then 9x squared plus 8. And they say, what's the horizontal asymptote? Well, if you look, I have a 1 and a 2. Those are my degrees, the biggest powers in both the top and the bottom. And so my degree of the top is less than the one in the bottom. Therefore, I'm just going to say horizontal asymptote at y equals 0. And that's it. You're done. There's no math. There's no math. You just look at it and you're done. Next one. If the degree of the top is equal to the degree of the bottom, then you have a horizontal asymptote at y equals the front fraction. Front fraction. It's kind of a weird Englishy thing. Let's do an example for this guy. Let's just say I have 15x squared divided by 5x squared plus 9. Well, notice here that my degrees are the same. And so what I want to do is take the fraction in the front and simplify it. So then I would get y is equal to 15 over 5, which ends up being 3. That's your answer. Y equals 3. That's your horizontal asymptote. Okay. Cool. That's why I say front fraction, because it's the fraction in the front. And the last one, if the degree of the top is greater than the degree of the bottom, this is my favorite one, no horizontal asymptote. There's just none. There's none. You're done. So quick example. 14x to the third divided by 3x squared plus 2. Sounds good enough. Well, notice 3 is bigger than 2, so you just say none. That's it. There's none. No horizontal asymptote. Okay. So I have the 3 rules. There you go. They're actually pretty simple. But there's a 4th rule. Yep. So let me do this one. If, this is a weird one, if the degree of the top is one more than the degree of the bottom, what do you get? You get a slant asymptote. Let me even write that out. Slant asymptote. So a slant asymptote kind of looks like this, and you're going to follow that line, so it'll kind of do something like that. They're fairly rare. Definitely not coming up on every single problem, but they will want to be, they're going to mention it here and there, of course. What's the formula for this slant asymptote? It's division without your remainder. Division without your remainder. What do I mean by division? Well, long division, synthetic division. There's a lot of things that are division. I like synthetic personally. Let me show you an example here. I got x squared plus 2x minus 35 all divided by x minus 7. And so I say, you know what? Synthetic division, division without remainder. I guess that's kind of like your formula. What's your 0 from the bottom? It's a 7. And so then I've got 1, 2, negative 35. 1, 7, 9. 9 times 7 is 63. And you add this to make it 28. And it says division without remainder. So you had an x squared. This is an x. If you look at this guy, it's x plus 9. It's more specifically y equals x plus 9. That's your slant asymptote. And again, without remainder. You just Doesn't matter what you got. Doesn't you got? Oh, I got a 0. I don't really care. That's not my point. Just get rid of the remainder. It's totally gone. Just erase it, and that's your answer. Very quick and easy. A little confusing, but it's easy. You just do simple synthetic division. Now, here is the big one. 3, 5, 67. They call this the 7 steps to success. Doesn't it sound cooler when it's like that? No, it's just the 7 steps. They actually call it that. And I'm only doing one of them. I think you probably got about 10 of these things on your homework. Okay, I'm joking. It's not 10. It's like 3, maybe 3. So, and some of them are easier than others. What are they wanting here? Let me start going through the list of what they want, and I'm going to give you a formula, and I'm going to actually do that with you, okay? Step number 1, they say, what kind of symmetry does this thing have? And they're really asking about even, odd, or neither. They might use the y-axis, origin, neither. Either way, they're asking for this stuff. Well, what do? I look at the powers. So right up here, I got a power 0, power 2, power 1, even, odd, even. Do we have both an even and an odd at the same time? That is correct. So you can't have both. I'm going to say neither. Most of your answers will be neither. Or none, or whatever. Step number 2. Find your y-intercept. How do you do it? And again, this is just y equals, and then there's going to be a box here. How do you do it? You're going to plug in x equals 0. So you plug in a 0 into all this stuff. You got 5 times 0 divided by 0 plus 0 minus 15. Basically, you get a 0. 0 is your answer. Okay. What are your x-intercepts? Plural. Because you could have more. And they're going to have x equals in a box. How do you do this one? It's when the top is equal to 0. So I'm just going to take the top, just the top, and set it equal to 0 on the side over here. Solve for x. Divide by 5 on both sides, and basically you get 0. That's your only answer. You put a 0 in, and you're good. Okay, number 4. Find your vertical asymptotes. Again, plural. And this one's a little bit more vague. They just have a big old box here. Well, how do you do this one? This is when your bottom is equal to 0. So I'm going to go and take my bottom off to the side. It's a plus 2 and a minus 15. And I'm going to factor. I'm going to solve for x. What two numbers multiply to make a 15 but add up to 2? It's a 5 and a 3, a positive 5 and a negative 3. And so then I got x equals a negative 5 and x equals a positive 3. That is your answer. That is your answer. And so you go and put it just like that because they want the x equals in your equation. Well, in your answer because it's an equation. Okay. Horizontal asymptote. Singular. And again, they just have a big old box here. How do you do this? It's the 3 rules. So let me go back and look at my powers here. I got a 1 power in the top and I got a 2 power in the bottom. The top is less than the bottom. That's rule number 1. And so that's going to be a y equals 0 is my horizontal asymptote. Y equals 0. And you have to put the y equals in there as well. Number 6. They say, make a table. Dun, dun, dun. And I'm going to copy down what they have here. -6, -1, 0, 5, and 6. And then they have a box for each one of these. And you have to fill it in. Well, they're not hard. And, well, you do have a basic calculator, right? You don't have to actually multiply by hand or anything. So I'm going to plug in that -6 here. Minus the 15. And we got negative 30. In the bottom, I got a 36 minus 12 minus 15. Yeah, this is a calculator. Okay, negative 30 divide by, and then use parentheses for the denominator if you're doing it all at once. I got negative 10 over 3. Okay, so that's what you're going to put in the box there. Repeat, repeat, repeat for each one of these. You'll get a lot of different numbers, a lot of fractions. Definitely use like your calculator. Everyone's going to have a calculator. Just I wouldn't say a graphing calculator. Just scientific stuff. It's easy enough. And it will any of the scientific calculators I know will definitely still convert it into fractions for you. So definitely fractions are fine. Calculators fine. You do that. I'm not going to do it. I think it's boring. So number 7 is my final step. Now they say graph it. Now, if we had graphing calculators, we would just plug it in and get it done. But because we don't, I'm thinking along the lines of using what we have. Notice that I have negative 5 and 3 are my vertical asymptotes. 1, 2, 3, 4, 5, and that's one thing right there. 1, 2, 3. I'm trying to make it. I'm trying to set it up. I'm trying to get a shape. What is it going to look like? My horizontal asymptote's at 0. So it's basically, this is my horizontal asymptote as well as the x-axis. It just so happened to be that way in this problem. So I don't want to cross that unless it's like absolutely necessary. I'll never cross a vertical. Never cross a vertical, but you can occasionally cross the horizontal. Okay, notice that we got this 0, 0 as my x and y intercept. It's right here at the origin is a point. And notice that I am actually going to cross through this thing or something at that one point. No other point, just right there. It happens sometimes. It's just how it is. And keep going. Let's see here. Neither, so there, we don't have any other, we don't have any kind of symmetry. Yeah, okay. We already used those. Okay. Oh, we got a table. I guess we can kind of use a table to help us out. So using a table here, I would say negative 6, negative 10 thirds. Negative 6 is like right over here, isn't it? Because that's negative 5. Negative 6, negative 10 thirds. I don't really know where negative 10 thirds is, but it's negative. So it's going to be down here. Something down here. I don't know exactly where, but it's somewhere down here. So there's another point. And all of these could be points that you would plot here as well. Now, I'm too lazy to do it, of course. So here's the graph, at least the part that I know. It'll do something like this, and it's going to kind of go up. I don't know what's going on here. I should have probably done some more things here. 0, 0, that's pretty easy. So, like, what's going on here at negative 1? Again, I'm tempted to go to my calculator, but we're training ourselves to not do that. And so I got a negative 5. I got a 1 minus 2 minus the 15. This we could do in the calculator, because this is just basic stuff, 1 minus 2 minus 15. And I got 5 over 16. Notice that it's positive. So I got a positive right around here. I don't know. That's pretty good. Okay. And let me just check something else out. I don't want to choose 5. I want to choose like 2. So it's not part of my list. But what if I plugged in a positive 2 right here? I want to see what's going on at positive 2. Now you might be wondering. No, I'm not going to let you wonder. Sounds kind of weird. I'm not going to let you wonder because I want to tell you something here at the very end. It's not bad. Everything's fine. We got 8. And then minus that guy, so we got 8 minus the 15, so 10 over a negative 7. Notice that it's negative here, so we're talking down this way somewhere. I don't know exactly where, but it's down. And so to me, it looks kind of like it'll do this, kind of cross through and then keep going. Just a guess there. And then what goes on at the very end? Well, if you go and plug in a bigger number, like that 6 or something like that, I don't know, because that's 3, 4, 5, 6, something way over there. You'll see that you end up with a big positive number. I don't care what that is. Actually, it's going to be a smaller positive number. It's a positive number. There's no negatives for sure. It'll be fine. Positive. And so then it looks kind of like this here at the end. There's my graph. A, B, C, or D. Click that guy, and we're done. Whew, that was amazing. And so I have to tell you here that I actually messed this problem up at the very beginning. Oh no, everything's fine. Everything's fine. In my math lab, this problem did not have an x there, so it was just x to the 0, I guess. All of what we did was fine. I'm just saying that this particular number randomization probably will not have an x there. So, sorry. But it's okay, because we did it, and it looks good, and that was fun. So, there we go. Everything was fine. So, my notes here say for me to repeat some more, and I'm not really going to repeat a lot. I just want to mention, I guess. I'm going to mention a couple more. So there's one that I want to mention. And here is another one that I want to mention. So let's look at these guys. Notice, when is the bottom ever equal to 0 here? It's never equal to 0. So there'll be no vertical asymptotes for this guy. That's kind of strange in this kind of environment. But I have a horizontal asymptote at 7. What happens, I believe, is it looks something kind of like this. I'm pretty sure. Something like that. So watch out for that. It is a strange one. What about this guy here? Well, definitely we could factor the bottom. So if I factor the bottom, like ahead of time, then I could say, what, 5 and 4? And you can see my vertical asymptotes are here. Actually, because it's 1 and 2 power, it's going to be a horizontal asymptote at 0 again. I have a 0 right here, so that's a 0. There's my vertical asymptotes. And I just start graphing it, just basically like what we just did a second ago. So, cool. I have 2 more problems, and they're strange, and we have to talk about them. Okay. This question here says that we have a monthly cost of $300,000, and it costs $200 for each bike. For each bike. Bike as in with a B. Like a bicycle. So they're making bicycles at this factory, I guess, or something. And so we have a monthly cost. That's my rent. And then I have $200 for each bike, which would be materials and labor and all that kind of stuff. And they want C of X. They say, what's the cost each month? This is super simple. You pay for rent, and then you pay $200 for every bike. That X is for every bike. And they'll talk about that in the problem. They'll use more English. They'll say, blah, 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 use an X or something like that. So you're not going to be left out from that. Okay. And then they have this C bar of X, which they're saying is the average cost. And we need to find that. It's actually just as easy. I'm going to take what I had originally, and I'm going to divide it by X. Now think about this for a second. I have, let's say I have a bill of $1 million a month. I don't know, something huge. I gotta sell a lot of bikes to be able to make up that cost. So I'm taking the total cost and I'm distributing it to the cost of each bike. Notice that labor materials is $200, right? But are you going to buy this bike for $200? Are you going to buy this bike for $100? No, because then we'd be losing money. We're buying this bike for like $500. We're going to make money. That's the point here. So then every bike, you're making a profit to offset both this cost and the rent. Economics. So last one. It says, hey, find the average cost if you produce 500 bikes in a month. Well, we have a formula for that now. And all I'm doing is plugging in a 500 into both places. And I got $800 should be the cost of each bike to sell so that I don't know, even out in the end or something like that. Okay? And then you just repeat this thing again and again. They're going to ask all these other numbers like, hey, what if you make 1,000 bikes? What if you make 2,000 bikes? Plug it in, plug it in, plug it in, plug it in. Okay. Last problem, 35101. This one's one of my favorite problems because it's so easy. I actually haven't done any math on this in like forever. But it has this horizontal line here at 6.5, horizontal axis. I'm sorry, horizontal asymptote, sorry. And it takes this dip down, and then it comes back up, and then it kind of levels off. Okay. What they're talking about is the acidity in your mouth. Acid mouth problem. It sounds pretty crazy. This is at 24 minutes. And then there's another point over here at 30 minutes. That's not the scale. I'm just kind of making something up. This is at a height here of 4.6. And then this is at a height of, I'm just going to make something up here. It looks kind of like, I'm just going to make something up, 4.7. There you go. Totally not the scale, but it'll be fine. So just whenever they ask, you know, here we go. So they say, okay, what's the pH level after 30 minutes? 30 minutes. Coordinate it off. 4.7. Okay. Hey, what's the lowest pH level? And they say it's at how many minutes? Well, the minimum is right there at 24 minutes. And they say, what is that pH level? That pH is, well, coordinated off as 4.6. I've gotten the same number here twice, by the way. They are very similar to one another. You're just looking at the graph to do this sort of thing. You're just looking at the graph like, hey, where's it line up? Okay, yep, okay, cool. Yep, nothing much to do there. What's your normal pH level of your mouth? If you look, it's going to be this horizontal asymptote thing, 6.5. Okay. Hey, what's the horizontal asymptote equation? Equation is a key word here. What you're going to actually put is y equals 6.5. And so far, that's all it is. And then the last question has English, and you need to click the thing that says it's going to get closer to the horizontal axis. Or I'm sorry, horizontal asymptote. I keep doing that. Horizontal asymptote. Gets closer to the horizontal asymptote. That's your final answer for that. And we're done. That's it. Whew. All right. Thank you very much. Have a great day.